What is going on today, people? I hope that you are having an amazing day and a blessed day. My name is Nasser, back at you again with a brand new math video. Today, we are going to, all right, today we are going to, or I'm going to show you how to integrate with U-substitution. What is U-substitution? Well, sometimes you cannot integrate right away, and you have to change the integral to make it easier to integrate. So you have to clean it up a little bit by substituting with U. So I'll show you how to do that. So let's just take a look at a few examples. All right. Here are all the types of problems I'm going to show you using U substitution. The first example is the most basic kind. And it's basically just a U substitution. It has a power rule in it. The second example has a fraction in it and a square root. And you'll have to rearrange the du expression to get what you need in order to integrate easily. The third example has a square root in it. And you'll have to manipulate, and this time you'll have to manipulate the u expression by subtracting a number in order to integrate easily. The fourth example has trig functions in it. And lastly, the fifth example is just like the first example, but it is a definite integral. So I'm going to show you how to adjust the lower and the upper limits when substituting u. So let's take a look at the first one. All right, let's copy it right here and move it with us. Move it with us. Move it with us. All right. So now, looking at this, I don't really know offhand how to integrate that directly, but I'm going to use a little trick called U-substitution. Now, why is it called U-substitution, you might ask? Well, no good reason, really, as far as I know. They could have used any letter, really, but, they used U, but it's U. It's just the standard. So we'll do U. So we're just, run with U. And what that means is that you are going to rewrite this whole integral in terms of the variable u, a new variable u. And the first, okay, all right, cool. So this is just the way it is, okay? Okay, so the very first step here, and it's just the most important step, is picking your u. And this is not really the most basic part, but it's just what you have to do at first is how to pick your u. Usually, this is what it looks like. It's something to a power, or a number to a power, or a square root, and there's something inside that. Fraction. And in the denominator, there's something with parentheses in it. Or we got a fraction, and down there there's a square root. So there's a fraction and a square root, the denominator. Or we have a fraction and something raised to the second power. So this is just what it usually looks like. Okay, it's just the basic kinds. So in this case, we have this. We have something raised to a power. So we're going to substitute u. So u equals x cubed plus 5. Now, this is the first step. The second step is finding the du. Find du by taking the derivative. Okay, we are going to find du by taking the derivative. Okay, so du equals. Now, what is the most famous rule ever? Well, it is multiply, so multiply 3, subtract, multiply, subtract, plus 0. Well, we don't really have to do that. Okay, now we got a very important step. Always write dx at the end of the differential because you took the derivative with respect to x. So always write dx. Now, and this is the most important part. Check to see if you can replace everything in terms of u and du. That is always the goal. So let's take a look at it. can we replace everything with u and du? Well, we got u in here, so we got this covered. So we got this part covered. Okay, do we have this part covered? Do we have this part covered or not? Well, we do. We actually do. We have this, which is the same as this. And we have this. Yeah, so this is basically it. So we have it covered. We're good. Okay, let's cover it with use. Okay. So this is basically du. This right here, and this is basically du. And we're gonna substitute this with u. Raised to the 7th power du. All right. Are we done? No, we're not. Use the power rule to integrate. Okay, we're going to use the power rule to integrate. What is the power rule? Add, divide. Okay, add. 7 plus 1 is 8. Divide over 8. Du becomes, so just plus c. So you might ask, what happened to the du? Well, when the integral symbol goes away, so does the du. So you can think about it like undoing the chain rule. It's like the inverse of the chain rule. The du just drops out. It goes away. Okay. So now, since we integrated, we have to do the 4th step, which is plugging u back. So plug back u. We said that u equals to this. So now we'll say u 3rd power plus 5 all raised to the 8th power plus c. Don't forget the plus c, because this is an indefinite integral, meaning that there are no limits. You have to write at the end plus c. Okay. All right. And this is the first example. Okay. Now let's take a look at the second example, which is this one. Let's move it with us. Move it. All right. We got a fraction, we got a square root. And as we said in here, this looks like this. Let's replace what's inside the square root with u. Okay, so u equals to 1 minus x to the 4th power. And the second step, as we said before, find du by taking the derivative. So du equals, this is 0. This right here is minus, as we said, multiply, subtract. So multiply, subtract. Don't forget the dx. All right, now let's ask ourselves, do we got it covered with use? Is everything covered with use? Well, no. Okay, that's new. If the answer is no, well, you got 2 choices. Either you're going to rearrange the u expression, or you're going to rearrange the du expression. Well, in this case, we are going to rearrange the du expression. Okay. Well, how are you going to do that? Well, as we said, we want it covered. Sorry, we want it covered with use. So what we are going to do is that we are going to divide by 4 in both sides. So what happens is, or multiply by 1/4. Okay, so we multiplied by 1/4. This is x to the 3rd power dx. This is after multiplying by 1/4. Okay, so now, right now we got everything covered. Why? Because basically we have this covered. So this is x cubed x, and this is the same thing, x cubed dx. We're going to replace it with negative 1/4 du. Also, we have the u covered. This is u, this is u. So basically we got everything covered. We're covered. We're good. We said before, we're basically covered here. So what we need to do is that we write everything and cover everything by u. So we covered it. So we got this. We got negative 1/4. And then multiplied by 1 multiplied. So I'm just writing everything. Just let it be clear. So this is basically what this is. Okay. And we got u at the bottom. We got square root of u. All right. Okay. One thing that you can always do is pull the constant out. We can always pull it out just to make it easier on us, and just it looks better. It looks easier. So negative 1/4, 1 over square root of u du. We can make it even easier. We can raise this. So what this is basically u to the 1/2 power du. We can, as Pam says, yumna this thing and raise it to the negative 1/2 power du, which equals. Okay, now add, divide. So we're gonna add 1, which basically is like 1 over 2 plus 2 over 2, which is the same as 1. So negative 1 plus 2 equals 1 over 2. Okay, so we're gonna add, divide. So adding and then dividing, which is the same as multiplying by 2. Okay, we got this. And then as we said before, plus c, that equals, now we're going to plug the u back. Sorry. So this is 2, this goes with this, comes 2, negative 1/2, then plugging the u back in, which was 1 minus x to the 4th, all to the 1/2 power plus c, which is the same as saying negative 1/2 square root 1 minus x to the 4th plus c, which is the same as saying 1 minus x to the 4th power plus c. So this is the answer. That is the second example. Pretty easy, right? Now, the third example. All right, let's start. Okay, we got the third example here. Let's start by the first step, which is picking the u. As we said before, this is pretty similar. This is pretty similar to this. So we're going to substitute this with u. So u equals x plus 2. Second step, find the derivative. This is basically 0, which is, so 0, and this is, no, this becomes 1. Sorry, so this becomes 1, and then this becomes 0. So dx. Okay, this is just to simplify it. You can write it as this, basically. Right, now, we have to ask ourselves this question right here. Check to see if you can replace everything in terms of u and du. Can we replace everything in terms of u and du? Well, in this case, no. I mean, we can replace this, but we got this x right here. How can we replace this x right here? We cannot manipulate the du expression because, you know, it's just du equals dx. We can't really do anything with it. What we can do, however, is to rearrange the u expression by subtracting. Well, how is that? Well, basically what we're going to do is we're going to find this x, which is basically this one right here. So what we're going to say is that x equals u minus 2, isn't it? So this is basically what x is. Now everything is covered. Now we're good. So let's try it. So the integral of x, what is x? Well, x is right here. X is u minus 2. the square root of u, which is this right here. And then we got dx, which is du. And that's it. Everything is covered with u's. Happiness. We're happy. All right. U minus 2 to make it easier for us. We got u to the 1/2 power du. We are going to distribute this right here. Bam. And then bam. So u and then 1/2 plus 1, which is 3/2, minus 2u to the 1/2 power du. Now the very famous quote, add, divide. So u adding. So this is 3/2 plus 2/2, which is 1, which equals 5/2. This is just to make it easier. And then divide. If we divide this 5/2, this is basically multiplying by 2/5. Okay, pretty simple stuff. 2, and then as we said, add, divide, u, adding, add, as 1, got 3/2. So 3/2 divide 2/3 plus c, because it's an indefinite integral. Okay, now this is 2. Okay, so now we've got 2/5. Basically, what we're going to do is just plug the u back in. So the u is x plus 2 minus, so 2 multiplied by 2, which is 4/3, multiplied by, plug back u in, x plus 2 raised to the 3rd half power plus c, and that is your answer. Yay. Okay, stop sharing. End it. All right, let's move on to the wait. Before we move on, we made a little mistake in here. We forgot the 5/2. And that is it. That's the right answer. All right. See, calculus is actually easy, but the hard part is the algebra. That's what always gets people tripped up. You know, in my experience as a professor, no, but on a real note, that this is really what gets people. This is the hard part. It's just the algebra. This is why we have pre-calculus. Right. Now, this is the 4th example, and there's a lot of trig function. No, it's pretty easy actually. One thing that I'd like to say is that if you get something like this that has a square root or a cube inside the trig function, it is much easier to rewrite it with parentheses. This is sort of a silly notation. So this is the same as saying cosine x cubed. So cosine cubed x is the same as cosine x all raised to the 3rd power. Okay, so we're going to make it easy on us by saying sine x dx. This is cosine 3rd power, sorry, x all raised to the 3rd power. All right. Okay. Now, we are going to substitute. As we said, this is a fraction. And, oh my God. Okay, so as we said, this is a fraction. And there's something in the denominator raised to a power. So we're going to use that as our u. We're going to pick that out as our u. So u is equal to cosine x. Okay, sorry, what was that? Cosine x. Du, so the derivative of cosine x is negative sine x dx. Don't forget the dx. Now, are we covered? We are very close to being covered. We have a negative sign in here. So we are going to move it to the other side by dividing. Divide by -1, divide by -1. This is negative du sine x dx. Now we're covered. Now we're good. This is this. And sine dx, which is this one right here, which is this right here. So we're covered. Okay. Now, let's put our u's. This is, sorry, this is 1. This is negative. This is du. Negative du. As we said before, we can always pull constants out. Same thing goes with negative signs. Okay. This is u raised to the 3rd power. Again, umnate. So u -3 du raised to the -3rd power. Okay. Add, divide. Add 1, which becomes -2, divide by -2, which is the same as saying -1/2. Sorry, so we're going to delete this. Yep, now we're good. Plus c. All right. Now, this is -1 multiplied by -1/2 is plus 1/2. U, we know what u is. U is cosine x. Cosine x raised to the -2 power plus c. And this is the same as saying 1 over 2 cosine x raised to the 2nd power plus c. And that is it. That is the 4th example. Okay, now we got the 5th and final example. So the 5th example is just like the first example, but it's a definite integral. Okay, as we said before, it's just definite integral. Is that any different? Slightly different, but not really. Okay, so what we're gonna do, same exact steps. Now we're professional with it. Now we're fast with it. U, some parentheses or something to a power, substitute by u, du equals, and now take the derivative, 2x dx. Now let's ask ourselves, are we covered? Well, we got the u in here. And we got this right here. Oh, sorry, let's use another color. Green, got this, which is the same as this. So we're covered. We're good. Let's move. Let's move. Okay. Got so this is basically u to the 2nd power du. Okay. Now this is different. Now as soon as you get rid of all the x variables and replace them with u variables, you need to adjust the lower limits and the upper limits using this expression right here. So what is u when x is 0? What is u when x is 0? So we're going to just plug 0 in here. So 0 to the 2nd power plus 4, this equals 4. So use 4. And what is u when x is 2? Okay. So let's plug 2 in. Plus 4. This is 4 plus 4, 8. So this is 8. And that is it. This is just the only extra step. This is just the only extra step. Let's just plug in the limits into the u expression. So let's do it. Add, divide. U add 2 to 3, divide. We got from 4 to 8. Okay. Now let's plug it in. Get 8 to the 3rd power over 3 minus 8. Oh, sorry, 4 to the 3rd power all over 3. And that equals 8 cubed is 8 times 8 times 8, which is 512. So sorry, 512 over 3. 4 cubed is 64 all over 3. Now 512 minus 64 is 448 all over 3, which is not divisible by 3. So this is the final answer. Yay. Yay. So that is it for me today. I hope this lesson made sense. If you have any questions, my office hours is all. No, I'm just kidding.